Yeah, so this is package specialization on the 27th of March. So let me share the agenda for today. I don't know whether anyone had anything on the agenda. So last week we showed the kept function, right? So how to write it. We did not complete it completely. I mean, the piece that we did not do is how to generate. The only thing that we did not show is how to generate a resource. The rest, I think we went through it. Are there any questions from there?
Go ahead.
I have
Yeah,
a question.
yeah.
Sorry.
No, it's okay. I can go ahead.
Go ahead.
No, you spoke first. It's okay. Go ahead. I can wait.
I raised hands, so you go first.
Okay, if you insist. So let me share the link. If we also went through what is in the catalog in the kpt.dev
Yes.
link for the Go, that also is a good one to actually try simpler, right? In general.
Yeah, the only thing that you have here is, so as I said last time, there is two ways to, or the SDK has two approaches or two options. One is, the one that we use is the less abstracted one. Mm-hmm. And in that we are able to add resource. So the piece that we did not do, if you follow the tutorial that is on the web, right? So here you see it uses the run context and then it abstracts these objects. So in this items, you cannot add an item yourself. So that's why we took we use the other approach, which allows it. So what I'm trying to say is I like the tutorial, but for us, for our use case, this tutorial has a shortage or so this the way to use the function SDK has a limitation that you cannot add those objects. And the approach that we took by using, so I'll show you, I think I have, so you see my code still, but I'll make it bigger.
I can see the screen.
So in this, so you see here that we use here the resource list processor function, right? And that is less abstracted. So in other words, what we get, or when we did the tutorial, so we get a resource list, which is the role list of items within the resource list. So you have the items and you have the function config and the results and stuff like that. And I did not show yet, but if we have time, we can do it today. So here you can just do an append of that items, and that's how you add the resource to it. Whereas if you take this SDK approach, so this items here doesn't have an add function. So we would have to create a PR to create that add function in that item. So at the moment, it doesn't exist. All right, okay. I reached out to Yumeng, who is the maintainer of this code, and she confirmed right now. So we have to add that component to it. So that's why so in our tutorial we didn't. So the piece that is different is actually the way you start it, and it makes the function library, so the resource list, less abstract, and as a result you have more options to. The only option that we are missing actually is that additional adding resources to the resource list.
I see.
And
okay.
Yeah, that's basically.
I think when we get our hands on, we probably will be able to. I mean, when we do it on our own, maybe we'll probably appreciate some of this, I guess.
Yes, yeah, correct. So that's the thing that I wanted to point out. But I do agree the tutorial is great. What I plan to do is the tutorial that we went through is I'm going to check that in such that you, with branches, you can actually follow each step and you have to go to a new branch to see the additions. So I'm creating a repo that has that so that you see all the steps that you need to do in order to accomplish the various activities.
Yeah, for me, what I found is running through this tutorial right now, the KPT, and then going through your recorded tutorial. really work. Double the introduction, and it really sink in. So that might be a good way to start.
Yeah, for sure. Yeah. Yeah.
But my other question is, so in workload automation, the one below, you hand it off. What's the CRD look like? Because I'm trying to write the SMF CRD, and I'm confused. In my head, they're very similar, and I don't get the distinction. It may not be the right forum to ask this question, but I want to raise it here. Like, what should I be expecting from specialization?
So what we get is what we have spec or try to spec in the CRD specification, right?
Yeah.
So let me, but okay, we have not shown you the full picture yet because we have to write all the functions. So, but
Okay.
what you get is a single container where all of these, all the IPs and the VLANs and the CFIN, which interfaces. That's what you get from us when all the functions are ran and complete.
Yeah,
so if you look,
go ahead. Sorry.
No, go ahead.
So
Yeah.
if I may add,
if I can share really quickly.
Sure.
Sure, I'm sharing that. So to her question, to Anne's question, Wim, sorry, it's not my question. I just wanted to add to her point. That's why. So essentially, from this package specialization team, right? To Anne's question, so what we are going to write a CR to just like UPF deployment, we are going to write a SMF deployment to the Git, right? And that's what she will going to work off of, isn't it?
That's correct. Yeah. So there will be two resources. So if you look to our PowerPoint file, so go back here, but of course the details are not here, right? So if you look to this, to make it bigger. Okay. Yeah, so if you look to this slide, right? So here you see the whole steps. So this is basically what we get. Okay, this is UPF, so you get an SMF deployment. So the ones, maybe I can color code them differently. So the ones that are actually going to be applied to the cluster, right? Because as you saw in the demo, there we are using this flag in kept. So I'm talking about, if you look back, did we show it? No, I think, yeah, here it is. So did we do it there? Oh, I did not attach it here. Okay, sorry. If you go to the package, the initial package, you see we are setting this flag, right? So this flag says this object, so this KRM object has local config equals to true, which means, so this is saying to the kept function runner, you don't have to apply to the cluster. So if you give it to config sync at the end of the day, these resources will not be applied to the cluster. So the network attachment definition, so I put here an example. Here, this flag is not set. And so for all the resources where this flag is not set, these will be applied to the cluster. So if you go back to our PowerPoint slides, so I just updated it. So what we were doing is to say, okay, these are the resources that are going to be added or changed, right? So which is colored like that. What I will indicate here is, so this is where this flag is not set. And so if this package, so what happens for us is all the conditions get resolved. Then at the moment, still someone manually will approve the package. So once it's approved, then config sync will pick it up. And config sync will only pick up the resources on which that flag is not set, meaning the ones that are highlighted in dark green or darkish green are applied to the cluster, and these will be then acted upon from the workload point of view, from the workload cluster point of view.
Yeah, but I don't think that was my question.
No, no,
Anyway.
your question is what is the content of this CR, basically, right?
Yeah,
Correct?
because anyway, never mind.
No, but I can, so if you go to the CRD, wait a minute, so Google
No, because
Drive.
there's a free 5GC CRD that we had used back in November, and I was able to bring it up for SMF. And the confusion in my head is how is that connected to the CRD that will be generated and handed over from specialization to workload automation, the delta, or if
It
they can be
it should
reused.
lie. See, we have two options. We either reuse. What I personally found is that CR is a bit weird because it has multiple N3 interface, multiple N6 interfaces, and so on and so forth. Whereas typically you only have one. So there
Yeah,
is
so I can trim that out, but I don't have enough background to know how much to trim. You know, like I'm struggling with creating the delta from the free 5GC to what we need to do.
So you want me to create? I can create a UPF deployment which comes from here that I would propose. So I can generate that, but I don't have it available as we go as of now. But I can generate one if you want, and then we can assemble an SMF because it's very similar.
Yeah. I guess what I'm struggling is I don't understand the network functions well enough to figure out, like, for SMF, you know, 1 and 3, 2 and 4, I think, or and 6, that kind of thing, and whether or not those will have IP already added, IP value actually integrated before it gets handed to workload, or do we have to do the workload IP apply?
No, the IP will be already there. So you will get a CR with all the IPs and VLANs, everything resolved.
Okay, so it will be a full CR, and then we just need to bring it up.
Yes.
Okay, then I think most of the work is done because we could bring up this free 5GC with many more interface NADs than needed. So I think it's doable already. Anyway, thanks.
Okay. Yeah. Bala?
So thanks. So I have a general architectural question. Do you think is it a good time to ask now or later?
Yeah, let's ask the question and then we'll see. It's
okay, cool. So you remember when we were talking about this, especially the package specialization part is the conditions could be introduced by the package management, and then we can satisfy it. And internally, architecturally, let's say we have different controllers. Those controllers could introduce additional conditions, and that could further be satisfied and watched by other controllers in this package specialization. So that is in theory of how the choreography should work as we spoke.
Yeah.
But I was thinking about that, but let's say we have one controller introducing a condition, and then that controller is automatically assuming that there is someone else to satisfy this condition. So, obviously, in terms of that means there is some kind of relationship and tight coupling going on here. I don't know whether it completely fits into the declarative realm, because we are already assuming at this point of time someone is introducing conditions and an actor is there to satisfy these conditions.
Yeah, so
that is one approach. If you give me a minute, the other approach is what you introduced the other day, where you wanted to have the placeholders, for example, for the IP. You took an example of IP, create the placeholder ahead of time, and may be able to create a tool for that to create those conditions ahead of time. And then even the package, that means even the pack when somebody is creating a package using the tool, those conditions could be created ahead. And then that means everything is very clear at the very beginning. So
yes, but you still in the second approach, you still have to know all the things that you are going to run, right? So
yes,
there's not much difference.
Yes, I think I like the approach you specified, because everything is known up front, versus coordinating controllers, which is fine, but I feel I don't know how declarative that approach should be.
I think they're both declarative. The problem is the thing is right now we have some limitations in the package management that we cannot inject as much as we want, right? So we have some constraints at the moment. So for R1, we are going to have very minimal capabilities there to what we can do, right? That doesn't mean it has to stay like that, right? But for R1, we are going to be constrained in how much the package variant can update stuff, right? So we have to make some more flexibility there. So we have some constraints in the context of R1, but the function behavior that we have doesn't change necessarily with it, right?
Right. Yeah. I just wanted to bring it up probably. But for R1, like you said, it's not going to be an issue. But overall, I just wanted to talk about it. Yeah. Thanks. I don't want to derail too much. Thanks. Yeah.
Yeah. Ravi?
Yeah. No, I was just thinking about Anne's point on the SMF. I mean,
Yes.
since we are doing it for free 5GC, I mean, that should be a good reference point. I mean, you just look at the Helm charts of, the manifest for the SMF. And I think right now, because it's a control plane component, performance is not a requirement there. So I would think it's just one interface for the control plane. I mean, what I'm saying is that you can also see the requirement from the bottom-up perspective. Ultimately, I think those are the manifests you're going to kind of provision, right? Yeah.
If you can see the screen I'm sharing, this is the SMF CRD.
No, we don't. We don't see.
Oh,
I'm trying to. I'll stop sharing.
Okay, I share now?
Yeah, I'm in the car right now. I won't be able to see
anything. Okay. But this is the CRD created from the Helm charts that Stephen had did, or cut and paste.
These are the services and stuff like that. That stays, right? So
that's what I'm asking.
Yeah, that's more than the manifest. Yeah, but yeah, sure.
Yeah, I like how much of this is to keep and how much of this is to. I lack the network function experience to understand what to keep, what to pair, and how to transform. That's what I'm stuck at right now. Do you see what I'm trying to say?
Yeah, but can we discuss that tomorrow? I think tomorrow there's a SIG workload session, right? So we can.
And my question really was, like, will you give me the CRD, or do I have to go craft one to play with until you have one for me? That's what I was asking. Anyway,
I can give you. I'll craft one and then we'll see. We can converge, right?
Yeah.
It's anyhow a good exercise to do. Yeah. All right. So I'll share it again. You see my screen? Yeah. So okay. So that's a bit the scenario. So what I wanted to do. Two things. One is we did not discuss the generation of the kept of a resource in kept through the kept function. And then I wanted to discuss a little bit the work split, which is probably it's better to go through this than to the follow-up on the tutorial, because then you can probably have a better feeling of what is needed there. So I added a few things to it. So I think when we left is this okay to see my screen? You can read it?
Yes.
Yeah. Okay. So I didn't change any of this. What I did change here a little bit is, you see here that I use, so now some of the CRDs are checked into the code, right? So I basically take the API version straight from the Nephew API as well as the kind. So I no longer use this text. So that's one thing that I changed, that you have straight access to the API resource from the library. And then the piece that we did not do is we said, okay, if cluster context exists into the package, we have to do something, right? And so I basically will show you two approaches on how we could do this. Let's start with the last approach. So in the last approach, what I did is I generated, let's say, a small library here, which takes an IP allocation in, and I created a parser on this object that marshals that data and spits out a cube object. And the way we populate the data, so in this approach, you basically populate that object. So you need to populate all the different elements that you have to that you want to use in the generation, and then what you do is you call the parse cube object, which is in that library, and if that is unsuccessful, you basically give the results back. So you say, okay, that's what is wrong, or if it succeeds, we basically append the items to that list. So this is the list. So in this case, I use the goal struct natively as is checked into the CRD object. Okay, so that's one approach that we can use. So and here you have access to all the data. I just populated a few, and for example, this is what comes out of this is what comes out of this, right? So that's an example of what was generated as a new resource inside of the package. Okay, so in this case, you basically populate just via regular Go structs. You populate the data, and then the only thing what is missing is, so what we would have to add into the CRD libraries is this parse object. So I just created it here, but this would go into the CRD part where we add this capability as part, and we could do it straight to this resource if we put it into the library. So we would add a method of parse cube object onto that resource, and that marshal. So we use, what important is that we use this library from Kubernetes, because there are, if you use a regular YAML v3, you see that you will get some errors when you parse it. And that's because they're using some nesting of the objects that the regular YAML library doesn't use. So if you use the SIG, so the Kubernetes YAML library, you don't have any issues with it. Okay, so I prefer this approach because it's I like this approach because it's rather straightforward, and you have the type validation that you have inside of the Go APIs. The other approach that we took, so we kind of mixed in the workshop, we mixed a little bit with various approaches. So here I created another line. So this is the NAD, but we could make the NAD in the same way as this one, right? Is that we created a small API on top of the NAD library, which is, so the library is here. I think, Steven, you used this approach in some cases, I thought. So I just did a bit of a prototype here with it. So here you give, this is our API, so that you generate, and then you use Go templating to actually populate the data. But you see that you, first of all, have to write more code. You have to build this API. If this API is not sufficient, you have to update it and stuff like that. So it's more, this is our argument against, one of our arguments against Helm. So which we didn't like because you build an API on top of a regular thing. So I just wanted to show it, that it's possible, but this is probably, I personally believe I would not propose to go for this capability, but rather use the other one. Any questions or comments on that? So the way to basically add that resort is if you look to the flow that we had, is so during the gather info phase of the function, we should list the elements or the data that we need for the population or for the generation or the mutation, as Vish called it. And then we use that data to actually populate these fields, basically. So that's kind of the flow that we would go. And anyone have objection of using this approach? Yeah, Vish.
My hand was raised not to raise an objection.
Okay.
It was to like, you said that you're going to push this code to GitHub. I mean, I know you're walking through this is great, right? As a next step for us to digest it, right? I know you have spent a lot of effort on getting this so that we can pull it, look at the code and ask very specific questions. Yes. Can this be pushed to GitHub even on your private repo? It's okay too. That way we can start, if you're opening it as a PR in your itself, we can go ask questions there and say, hey, can you please explain to me a little more detail? That means that way our PR comments can be used to actually be used in this session to go through that.
Yeah. What I'm planning to do, Vish, is the following, and maybe let me know, because whether you agree with or not. So if I look to some of the tutorials that people do, so of course this building this function, if I just put all the code in once, it's one big blob, right? So and then you have to find out what has to be done. So what I'm planning to do is, like we did last week, is we started from scratch, from zero.
Okay.
And then we added the first thing is, how do we get access to the resources? So my plan is to build a repo that does the following, is then branch number one is step number one, right? I will call it step number one, which is how do we initialize that function SDK, right? And then we go to branch step number two in the branch, so which is another branch, which is a build-up from the first branch, and which adds the elements to it. For example, how do we log stuff, or how do we do errors or something like that? So that would be step two. Then we had branch number three is step three, all the way up till you have the full thing. So that's basically what I'm doing. So, and then you can, of course, the last step has everything, but you can see how we got from step two to step three, and you can do a diff and what have you.
So, but every branch, are you planning to push it, or you're not planning to push it, or you're planning to first go through this?
No, all the branches will be pushed. So there will be one repo, but in the repo has branches that are not committed to main, and those will contain the deltas from the previous branch.
Okay. Thanks.
Yeah, Pala?
Yeah. I apologize. I had a brain fade moment. If you can please summarize the difference between the two approaches, if you don't mind.
The two approaches is so here in approach number one, right? So I'll put the comment here for now. So what you do is you take so what did I do is I took the regular Go. So if you create a CRD, you create a set of Go structs, right? That I basically build up that CRD. Which is, so I took here IP allocation. So this is the CRD, and V1 alpha 1 is the IPAM one, right? So I basically point to the IPAM IP allocation CRD. And what am I doing is I'm populating the structs directly in that CRD, right? So here I have type meta, which is the API version kind. From it, the object meta, which is the name, you can put the namespace, labels, you can populate all of that. So, but in this approach, you basically take the native CRD Go struct and you populate it that whole construct with all the attributes that you want in that YAML manifest to exist. And then, so that's what you do here. And then you basically, I create a helper function as that is attached to this object. Actually, I have an indirection right now because I don't own this object. So I did a bit of a trick, but the idea is to make that part of this object. And when you call parse cube object, you get, as a result, you get basically this return, which is a cube object pointer, which contains that YAML file. And that object is needed for the function SDK to add to your resource list, because that will then be the basis to generate that KRM resource from. Right? So that's approach number one, native constructs, and so on and so forth. Approach number two is you build a small API that you use in your code, right? So here I basically create an abstraction. So I said I need for my NEDs, I need a name, I need the CNI version, CNI type. So this is kind of, you could think of this as the Helm values file. For those familiar with Helm, is a new API on top of the thing that you want to generate, okay? And then that is used as an input. And then that is basically then used to as input in a template. So basically I use this configuration file in the template, and then I each of these parameters I access through that template, and I generate so I generate a template with that data. So with that API, that's new API, I execute the template, and I then do the same object here. So I generate a cube object file from I threw the function SDK in the same way as I did in the previous thing. But you see here that you have, first of all, you have to build this API on top of your existing system. So this is an abstraction on top of what is already available. And you basically then parse it. This is a gold template. You have other mechanisms to do this, but so you see that you have to write all of this code. An advantage of here is, for example, API version and network attachment definition. The kinds are kind of hard coded, right? Whereas here in the previous example, so in the first example, I actually have to populate that because it's a naked construct. So you even have to populate the API version and kind. But so that's the only disadvantage you could say, is that, okay, I have to always populate that, although it should be coming straight from here. But yeah, it is what it is. Yeah. And we could abstract that potentially in that parse object if you want, that we always override it over there. So we could say, okay, if you give me this function, that we override it always and do that override there. So that's another approach, in which case it's hidden from the user. So that's the difference between the two approaches.
Got it. So, and you're suggesting to do the natural way. This is the natural way to do things. Now I understand. Thank you so much.
Approach one. Yeah, I propose to do approach number one instead of approach number two.
Yes, I totally agree, because approach number two, something changes, you have to maintain the new object. You have to update the new object. So I totally agree. Thank you. Yeah.
Correct. Yes, Akash.
Hey Wim, thanks a lot for this. So my question is, I think approach number two, I'm just raising a point with approach number two, is that if I'm able to write my template and have it outside, I mean, right now the template is part of the code. That function says that this is the template I'm using. Now, if I can move this template out from the code and make it as a template file, I'm just thinking that it's more like what Helm is going to do. So that means that we are not going to make changes to the code every time an IPAM schema is getting changed or something like that. So from our side, the code does only worry about whatever the template, I'm going to plug these values in, right? In approach number two. But in approach one, we are kind of hard coding the schema into the code, right? So I kind of feel like, so that means that we are going to change the code every time the K8s package is going to change the schema, right? So do you think that that is a problem, right? I mean, approach 2 is solving it by, if we can put it outside of the Go code. So the Go code doesn't change, and it is kind of more, the change is basically now you have to update the file and there is no change in the code. But this is going to have an entangle, this is kind of creating a dependency on the schema, because you're kind of now saying that spec has prefix kind and network instance, which this code need not know, right? I mean, it needs to know only what,
yeah, so these values, so what you're proposing is basically a mix between 1 and 2, right? So you could actually build an API on top of 1 even if you want. But what you always have to bear in mind is that every abstraction you build, the abstraction is as good as the abstraction is, right? So if the abstraction is not detailed enough, you will have to change the abstraction layer, right? And so in other words, what you're basically saying is, I could have taken approach 1, right, and built a similar API on top of it like this, right?
Yep.
And then the library does it, which is a mix between option 1 and 2. And the advantage of it is, as you said, is that the struct is abstracted, but the challenge is always to ensure that you have enough attributes there. Now, what we are doing is very simple, right? So I don't think this is very advanced, and typically the parameters don't change much, but it will evolve, right? So so in both approaches, you will have to do something if your abstraction is not good enough, right? Whereas here you will always have the code. So it has a bit, there is pros and cons of both sides. Don't get me wrong. The question is, what do we start with a little bit?
Okay.
Yes.
This sort of tied back to my question, because in my head, it's not clear the flow from the package group, subgroup, from John's subgroup, right? There will be a CRD passed down, and then this subgroup will start filling out some of the values, right? And then what you generate will be consumed by the workload automation subgroup. So what Akash said is very familiar to me when I work at Cisco and VMware and places like that. We had free marker templates, which are XML based because netconf, blah, 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 yang. And then we wrote Java code, or now Go code, to do this value substitution and generate a fill out template, a fill out CRD type of file, right? A full template. And then the NSO, the orchestrator consume it, the controller consume it and apply the changes. So that's why maybe that's the wrong paradigm in my head, but that's how I keep thinking about this. And that's how I'm struggling with what this 2 approach will generate. Do you see what I'm saying? I'm babbling.
They both generate KRM resource, right? So the result is from both is the same. The difference is between I took approach 1 is very raw, right? So that's native Go struct without any abstraction. Approach 2 is you have an abstraction that you build on top of it, and then you populate the schema. So these are the 2 approaches, if you will. Now, the implementation in approach 2, I took a templating approach to generate them. You could actually combine it with approach 1, where you use the native Go structs to populate the thing. So both are possible. I think the discussion is, do we add an API on top of, do we put a layer in between to generate our CRDs or not? I think that's the key question. But the end result is going to be the same. The difference is that your code that generates them is less, so you see less of these details in your code.
Yeah, and I would veer toward less detail and less enmesh, right? Less dependency, because if we have different NF packages from different vendor, we may end up with code specialization, right? Or am
Yes,
I
but what you
not getting it?
what you see, and that's the whole discussion that we have between configuration as data and Helm, will
Yeah.
end up exposing all the details in that abstraction.
Yeah.
So you can ask yourself now, there will be things where it's probably, so this doesn't change. So this you could already abstract. But
Mhm.
I would argue with you that every parameter that you see here, you probably need an abstraction for at some
Exactly.
point.
Yeah.
So, and then that bears the question, does it make sense to put it?
To put it, that's where, sorry.
To make an abstraction or not. So the abstraction,
Yeah, okay.
if you have to expose
Got it.
all the parameters that are in that CR, then the value of an abstraction is low, right?
But isn't the CR the abstraction, or am I confusing?
Yes, but what we are talking about is we collect a set of parameters, right? So for example, to give you an example, when we do a pool, this prefix kind is not prefix kind network, but prefix kind pool, okay?
Yeah.
So that means that this parameter, depending on how you use it, you have to already expose this parameter when you build an intermediate layer, right?
That's true.
Okay, so, and I'm
Okay.
arguing with you that all the parameters that are here, right? You see, these are all the potentials that you'll end up exposing them at some point, right? Now, what is the value of the abstraction is that you don't see the underlying detail on how that is built here, right? But
Mhm.
that's
But we
not
still exposing it.
huge.
Yeah,
Yes.
got it.
And that's a bit
I
the
missed that
chicken
point.
and egg. It's a bit the chicken and egg problem. Now, this, for example, okay, that I would argue that will never change. So this you can, but that we
Yeah.
could already take away. But all the rest is kind of going to be changed depending on how you use it. So that's the dilemma between an abstraction or not.
Actually, the first part, the IPAM v1 alpha 1 may change, but not as often, right? Because it might be
Yes.
IPAM beta 1 or whatever.
Yes. Yeah. So these are the things that you gain potentially, right? The question is, what do we do from the beginning? Do we keep it? Do we do it or not? Is a bit.
So to push the question one step further, based on your experience, Nokia and real world, so to speak, what's the preferred approach?
See, I always like to make the code less knowing the details, but in this space, for example, I played with a bunch of abstraction. You see that some of them you always have to update, in which case I question the value of it.
Okay. I'll yield the floor. Sorry to take so much time.
Yeah, no worries. Nala, yeah.
Thanks, and useful discussions there. I think Akash brings a good point. Thanks, Akash. Appreciate that point that you brought in. So, so there is this. What is we are struggling to come up with the approach. The one is kind of very imperative way of doing this, like the approach 1 versus approach 2 could be slightly more declarative, more amenable for it. For example, we could use reflection or the templates that the example that Wim has presented us. So that is the approach 2. So what we could do for the release.
Yeah, go ahead. Sorry.
Yeah. What we could do for release 1 is this is what I have done when I'm at crossroads like this, solve it in a very natural way, and then learn from that. For example, I know at this point of time we have to solve UPF and SMF. I'm not even sure ASF. I think it's not even in the picture at this point of time, I guess. So, so we could, and obviously we had to be a very general CNF orchestrator going forward, maybe a few releases down the road. So what we could do for the R1 is take a very natural way of solving things like what Wim is proposing, which is approach 1. And then to Akash's point, I think we should consider the need and the merits of declarative approach and templates / reflective programming. And then for the R2 onwards, we could do something like this for both. I mean, there could be some code duplication for SMS and UPF in this way, because they may have different inputs. And then once we do that, once we see it in action, we can learn from the lessons and go and refactor that part for R2 to make it more declarative using templates, is what I'm thinking, because this is the most natural way at this point of time to solve this.
Yeah, we could do a mix between approach. I would not use the templating thing, because this is really type safe. So this is the most type safe thing, because here what you see is that in approach number 2, you lose some of the type safeness potentially. So what you could do is you could basically take, for example, a new folder. Let's say I will create IPlog2, right? Where you generate, so let me do IPlog2, go, right? So what you could do in approach 2 is package IPlog2 or something, and then we basically say, so we do something similar than here, where we say, okay, here we have, so what I would do for approach 1 is to is in the mix would be the following, is that we don't expose the full, so you expose the spec or something like that, so like specific parameters, but they are still type. So you say type config structs, right? And then I'm just saying out loud where the name is, for example, the namespace, and then some labels or annotations are in like this, and then you for example say, and by the way, this code is not good because this should be uppercase, where the spec is, for example, the IPAM v2 spec, because then you don't aggregate it. You see what I'm trying to say?
Yeah.
So where this is, it's like that. And then, yeah, something along those lines, right? Where this is still a pretty type safe thing, and then underneath you could aggregate something like that potentially. So
Okay.
it's a minimal layer. It's a very minimal layer in between, and then you have a little bit what Akash was proposing towards our point, but it's still, you don't aggregate the spec, so you still have detailed availability of each of these parameters here, right?
Okay. Yeah.
So you would do something like that. Yeah. Does that make sense?
Yeah. I mean, like we said, I mean, we should not be afraid of refactoring later. So we can start with the natural way, like you're suggesting, Wim, and as the need arises, we can refactor. Yeah.
Yeah. So you do something like that, right? And then here you get this code from here. You do something like that, right? Yeah, I will probably not have time to code it up, but I'll share the example as well. Then you have 3 approaches, so it's like a middle layer, but I think that's probably the more interesting one. But okay, we can look at it. Yeah. Okay. Now let me maybe go through the work split a little bit, just because we, if you look to our milestones, so we have now our cadence that we have to follow. So for tomorrow, we have to deliver our design proposal for package specialization and building blocks, which for me is kind of the PowerPoint. What I propose, so what I'm going to start work on is create MD files for each of these functions and have one MD so I'm going to wrap that into MD files and this is going to then be the basis for our design proposals that we are going to use for each of these functions. Probably not as detailed as you saw into the code, but at least laying down the flavors that we have. And that would be our basis for our design, right? And then, so that is what we are supposed to be delivering by tomorrow, right? And then our next deliverable is a set of refactored functions. So what I propose, because we have to refactor, so IPAM injector is kind of done. I just need to add some tests here. But what I would propose is that we try, do you think it's feasible by the 10th of April to create a first version of our functions that we have in our specialization? And at the moment, the people that I listed, so I took this file a little bit, our work split. I think Ganesh and Saurabh, Ganesh, I saw, is Saurabh also on the call?
Yeah.
Yeah. By the way, Saurabh, are you also in India?
Yes, I'm in India.
Ah, nice. Because then maybe we could, because so both you and Saurabh are the ones that are signed up for the creating our functions. So what we could do maybe is we could try to do a working session between ourselves in India time zone, because I'm in Europe this week, right? So probably easier. And then try to, because my proposal or my question is, do you believe we can, by the 10th of April, which is 2 weeks from now, do we believe that we could have a first implementation of these functions? It's probably not going to be fully hardened and what have you.
Hi, Wim. So before that, when can we have that session? Just for the function?
Anywhere you want. So I can do it tomorrow if you want.
Yeah. But I think can we work on? I mean, can we finalize the timing tomorrow after our session quickly?
Yeah, sure. We can do. Yeah, I'll reach out and then we can try to get something assigned. Yeah.
Sounds good. Saurabh, is that okay?
Yeah, Ganesh, it's okay, Paul.
Okay.
I'll ping you via Slack, right?
Sure.
Yes, sure. Thank you.
And I'll try to agree on timing. Yeah. Okay. And then so the thing so when I look at the libraries for the CRDs, right? It's actually the approach 1 or the mix between 1 and 2 that we would add it here. But what I propose is that, is it okay that we try to do a small session with the people, with Ganesh and Saurabh, just to get this going, and then we can come back to these libraries on what has to be done there, and probably have a more meaningful proposal, and then we take this forward. Because if we are able to do that, I think our milestones for the next sprint, if you will, would be accomplished, which would be great. I think. If that makes sense. And then, so then the next sprint, when is that? So 24. So 24, so I'm working in the back on the VLAN side, which is very similar to the IP, but that's the next thing that we will add then. But yeah, I'm trying to avoid having to rush too much. So I think we still have, if we have 2 weeks, I have the feeling we can do it. But of course, I need to discuss with you, Ganesh and Saurabh, to see whether this is feasible or not and how we approach it. All right. Anything else for now? Yeah, Fish.
Yeah, a general question. For any of the tasks, will we actually have some sort of a story describing what we're going to be doing, what the acceptance criteria would be? Because that will give us a good brief of what the scope is and what needs to be done. Is it the next set of steps that will happen?
Yeah, I think.
Yes.
Yeah.
Okay.
Sorry,
so what?
may I take that question. Yeah, I think one of the things, Mesh, is I think John said he's going to create some stories. We have already populated a few stories. We will make sure that we'll populate it, and obviously, I mean, for the description, the subject matter experts, I will try to take a stab at it for the remaining stories. Then at least for sprint 1, whatever John is left, and then probably experts like Wim, John, Stephen, Tal, they can fill in the details in the story if it is something missing.
Yeah. But for me, the deliverables on how I look at it for these things is we first will create a design spec, so an MD file, right, which I'll build a skeleton for tomorrow. Then, of course, we write the code, and the deliverable for this is code plus test coverage, right? So we need to create the test that help it, and that's the same for this thing. Here we don't have to make a design document in my view, because that's just code with libraries. So here it's basically code and unit testing that we have to deliver. So that's how I look at it right now, that what we have to do as a deliverable. And I think if we come up with some, let's say, a proposal that will help everyone of what that means, right? So that's what my take is, that we build this for the first function together, right? And then we can split off somehow and then share it and get comments around it. Okay. Ganesh?
Quick add to that, in the design spec, I think an enhancement to your existing slides with some examples, I think would take us a long way, to understanding exactly what is required. And my second thing is like, maybe it's a general question, maybe it's too late to ask again, but so in your slides, we have various controllers and various kept functions. What will be the order of execution, and who will be executing each of these functions for our package specialization after it comes back from the package management group?
So the way it works is the following. By the way, we will be scheduled already before, we will already be scheduled during package management. And maybe let me rephrase again. I think we discussed or we touched upon it, but maybe it was not so clear. So these functions, there will be one more function, by the way, which, so these 3 functions, so we will be added them to the pipeline, right, of the kept file. So Porch is the one that executes them. So when you check in a file or when you do some changes, and Porch will, when it runs, it always runs the pipeline against these things. So that means that these functions, that's why I was focusing on the robustness and the idempotency and stuff like that so much, because they will be executed even at the beginning during package management. But given that we have no data or no context, they will not do anything, but they will be executed. Now, so the way it works is the following. So Porch, for every package, so Porch has various resources. One of them is a package resource revision resources, so which basically contains it. And okay, a function is executed as part of a pipeline, but the controller is executed based on this package revision resources. And Porch, there is a watch that you attach to that package revision resources, and Porch schedules it. So, and I call this so we call this the choreography, or I call this the condition dance. Is the way we have to put this pipeline in place is in such a way that that the conditions finally will be met, and then when all the conditions are met, then Porch will be saying the package is ready for the next stage. So it's actually Porch that is in charge of all the scheduling of it, and each of the conditions, they work independently, but they will result in all the conditions being met. Did that answer your question?
Yeah, but who adds this pipeline, various controllers and functions to the Porch? Like, is it part of the script?
No, this will already be part of the blueprint. So in the blueprint, we will add these functions.
Oh, okay.
The KPT file will have that.
Yes.
As part
Yeah.
of, as part of the mutator.
Yes. Yeah.
And it will be containerized, of course. This
I'm
each
sorry,
and
Yeah.
sorry.
These functions run in a container. Yeah. Correct.
So each function runs in its own container. Right?
Yes. Yes.
Okay. Okay. I'm sorry. Which PPT were we talking about, Vish?
So the KPT file. So if you look to the example in the KPT file, I commented out pipeline because we don't have our functions, but each of these images that you see here will be one of these images.
Okay. Okay. Got it. All right. So for a specific package, the pipeline will also already be part of the KPT file, which will be executed
Yes.
by push. All right. Okay.
Yeah.
Okay. So I saw some of the diagrams that the community, like some members made. So this will all happen after the cluster specific repository is created, right? After the fan out has happened.
So these pipelines will already be part of the blueprint package. So we will add these already in the blueprint package, and then when a package variant set is created, yeah, I need to jump on the call. When a package variant set is created, they will be fanned out, and then but these pipeline functions will not change. So what I'm trying to get to is the functions will already be in the blueprint package from the beginning. So our blueprint package contains them.
Understood. Okay. Thank you.
Yeah. All right. We ran out of time, but yeah, and I need to jump on a call actually. So thanks for joining, and we will be in touch on Wednesday. By the way, one more thing I forgot to say is that the Thursday slot I gave to the Orange people who are going to build an explanation on what they did to bring up all the packet core, the 3.5GC. So they are going to explain all the things they had to do to bring that up. So on Thursday at 8, I updated the agenda, but I'll send a note on Slack as well. So the Thursday slot is taken by the people from Orange, where they're going to explain that.
Is that related?
But we'll meet on Wednesday.
Is that anything
It's
to
related
help with our R1?
Yes, because you remember that we were stuck with the UPF comes up, but it never got the right permissions to add the filters and stuff like that. So they have found ways to accommodate that, as far as I can tell. And they have a full core up and running, so they are going to share with us. And the reason we accommodated them is because we believe it's useful for our one.
Okay,
so,
cool.
Yeah.
Thanks, Phil. Yeah. Have a good one, everyone.
Yeah. Thanks. Cheers.